Okay, consider I explain again the example. Are you ready or not? Not yet. Boleh?
I'm ready, doctor.
Boleh, sir.
Okay. Okay, consider this what we call simple application. For example, we have starting point here. Ni kat sini. Sorry. Starting point. Starting point. Then our goal at this point. This is our goal. So the main what we call the main goal is to reduce the movement of arrow ni. Okay, the movement. So how to represent this problem? So we can represent using this what we call this chromosome. For example, we have 4 movement 0, 0, 1, 0, 1, 1 and 0, 1. Okay, like this lah. Okay, should I explain this figure? No need, eh?
I'm
Yes.
okay, sir.
Hmm?
I'm okay, doctor.
Yang lain?
Okay juga.
Sound not so sorry. Sound. Okay. So you okay ke the based on this figure ni, so we can use this symbol or this what we call representation, this one. Okay, 0, 0 for north, 1, 0 for east, like this lah. This is first movement, second movement, third movement, and so on. So the complete movement like this lah. Okay, and then how to solve using genetic algorithm this problem? So first we consider the what we call population. So we set number of population. For this case, we set 4, but here just show 3 chromosome to reach the what we call the goal. Okay, so we have here black color represent black arrow. Okay, red color represent red arrow, and blue color represent blue arrow. So you can see the what we call the movement, okay, of each arrow ni, each color ni. So represent this one for black, for red, and for blue. I think no issue kan? Boleh kan?
Boleh, sir.
Boleh, doctor.
And then after we define what we call the representation of population or chromosome, so we need to define the finite function for this problem. So our finite function, for example, like this, fx equal to number of step. So minimum, this is minimum. So the lowest value mean the best chromosome. Okay, the shortest movement lah. So mean the best or the best quality of chromosome. And then after we define the chromosome, and then we do the what we call the process, the iteration number 1. So we should what we call we should repeat the process. Okay, we should repeat the process. So after we do the crossover and mutation, we need to select the candidate, the best, or the children, the best children. So we can use this technique lah, using rank-based survivor probabilistic greedy technique. But usually we using elitism lah. We just compare the quality of chromosome. So the best quality of chromosome we put as a parent, and then we do the crossover and mutation, and we follow the same process again, and then depend on how many iteration you define, 100 iteration, 1000 iteration, and so on. So the process will keep continue or repeat till 1000 iteration. That for selection. And then the propagation, the next generation is generated from the fetus member to the current population. So we using this operator lah, or this operation, which mean crossover and mutation. Crossover for to combine or to recombine the like this lah, to recombine
Excuse me, sir.
the
Screen macam freeze. Screen
oh
sir.
yeah, so sorry. Oh, freeze Sekejap. Okay, this one. Okay, boleh.
Alright, sir.
Okay, so I I'll go back. The population. This is the sample example of movement of the arrow, black color, blue color, and so on. So based on this arrow, we can write. Okay, we can represent the movement like this lah, like what we call the representation 011000 and so on. Okay, and this is the fitness function. Fitness function mean the what we consider the minimum step. Okay, minimum, not maximum. Minimum mean the best chromosome lah. Minimum movement. Okay, so we need to find the shortest chromosome for this case. Then for selection, we have many types to select the children. So maybe we can use rank-based, survival, probabilistic, greedy, and so on. So usually we're using elitism lah. I mean, we compare the list of chromosome. So we choose the best quality of chromosome, then we put as a parent that chromosome. Then we follow the same process, crossover, mutation, and so on. Then we evaluate again the quality of chromosome, the children, and we do comparison quality. So that we call elitism process. Elitism better than, I mean, simple compared to probabilistic and so on. Okay, then the propagation, the next generation is generated from the fetus member of the current population. Mean at this process we have two operation, mean crossover and mutation. So how to do the crossover like this? This is the first point crossover. So I think should I explain again? I think no need kan?
No need.
No need kan? Or mutation by random. This crossover also by random. The point to crossover this point is random. This point random. So we can random. Or we can do at this point. Or we can do at this point. Depend on the computer, how you define the program. The mutation also we do by random. Okay, random also. Okay, consider this what we call this simple example. We have size 4 by 4. Okay, kat sini 4 and 4 ni. The population we set 4. Okay, and then the bit, I think this is not 16, actually 12 bit, because you consider this what we call this point. This is starting point. This is our start point. This is our end point. Goal end. Okay, then the best movement 1, 2, 3, 4, 5, and 6, not 8. Okay, this is 6 step, not 8 step before reaching goal. So the fitness function is 6. I mean, the 6 step is the best, what we call best movement. If more, mean not good. It's less, cannot reach the goal. So at least 6. Kalau you buat kat lain, so usually 6 step. Okay. And then for 6 step, we have 6 what we call 6 sector we should allocate. 1, 2, 3, 4, 5, 6. And then for each sector, we have 2 beat, 0, 1 or 0, 0 or 1, 0 or 1, 1 or 0, 0 and 1, 1. So we only have 12 bit, not 16 bit. That's why for this case, 12, not 16. Clear or not?
Clear, sir.
Clear, Doctor.
Yeah. Okay, then first, how to solve this problem? So first, we need to put initial population. For this case, we set 4 population, okay, by random. So because of 12 bit, not 16 bit, so we remove the last 4 digit. We remove. So we only have this chromosome aja lah. Ni for P1, for P2, P3, and P4. Okay, so for P1, kalau you tengok, for P1, the what we call the movement 0, 0, 0, 0, consider we have 4 movement 0, 0, 1, 0, 0, 1, and 1, 1. 0, 0, north. 1, 0,
1, 0, east.
east. 0, 1,
West.
west. 1, 1, south.
South. Yes.
Okay. So kalau for this one, you tengok kalau this one we start point, this is the starting point. 0, 0 north. Kat sini. Lepas tu based on this random, I mean the random value ni, the random value. Ada orang nak masuk sekejap. Susah. Kejap I kena ni dulu kejap. I cannot keep sebab nanti dia save. Okay, and then 0, 1, 1, 0, 0, 0, 1, 1. This one, sorry, this one, north kan? 0, 1, north kan? Apa lah, north kan?
West.
Oh, 0, 1, west. Okay, sorry. 1, 0,
East.
yes. 0, 0, north and
Yes.
south. Okay, saya ulang balik. Okay. This is the starting point. Okay, so for P1, P1 ni, kita consider P1, 0, 0, 0, 0 north. Lepas 0, 0, first movement, second movement, 0, 1. 0, 1, west kan? West, so west, we cannot go to the west because this is maximum. So we just stay at this point also. Okay, no movement. So 1, 0, 1, 0 is this third movement. Okay, third movement, 0, 1, 0, 1, west, pergi balik kat sini. 0, 1, 1, 1, south, pergi balik kat sini. 1, 1, south, and then 0, 0, north. Pergi balik ke atas, north, north, 0, 0, north So dia punya end point kat sini. This is the end point. This is our goal. So this is end point. So to reach a goal, so how many movement should we have? So this is first, second, third, fourth, and last, 5. So mean for this case, the fitness function for FP1 ni equal to -5. Clear? Yang ni tak betul lah sebab yang ni kita dah jadikan 12 bit. So yang ni tak betul. Yes or no? Clear or not?
Clear.
Clear, sir.
So same case for P1, P2, P3, and P4. So, and then you compare, maybe this one -5, this one FP2 -3, for example, to reach goal. This one FP3 maybe -4, FP4 maybe -1. So the best chromosome P2 and P4. So you put P2 and P4 as a parent, then you follow the same process. You evaluate again, do the crossover, do the mutation, and so on. Then till you reach the goal. Mean the best equal to 0. No movement. Mean the end point equal to no movement. 0 mean no movement. Kalau -4 mean you need 4 movement to reach goal. Kalau -1, okay, you need 1 more movement to reach goal. So kalau 0 mean you reach the goal. Clear?
Clear.
So what we call that we call the ni lah, the process, how we using optimization to solve this game or this problem. Then this is the same thing. Sorry, ada orang nak masuk lagi. Sekejap. And then the what we call the crossover. Ni after crossover, then this is the mutation. This mutation. This is crossover. So I think no need to explain about ni. No need to explain crossover and mutation. I think you all know already the ni. To finish our this topic. So anything that you want to ask or you want to share or you want to give some idea or comment whatever. Ada soalan before we proceed to the tutorial tutorial 2?
Sir, I have a question. With crossover and mutation, we need to do crossover before we do mutation, right? Or
Yes. We need to crossover. After crossover, mutation.
kalau dia tersilang tu tak boleh lah.
Tersilang macam mana?
Means maksudnya buat mutation dulu and then baru crossover.
Tak boleh. Dia punya ni, dia should do the crossover.
Okay.
Then after that, mutation.
Alright. Okay, itu saja soalan saya.
Yeah.
Thank you.
Okay, kalau tak ada soalan, we proceed to tutorial 2. Yep. Okay, nampak tak tutorial 2?
Nampak, sir.
Nampak sir.
Okay, nampak. Okay. So for tutorial 2, question number 1, I think you can do. Question number 2 also, I think you can do based on our notes. Question number 3, question number 2 we discuss je lagi. This is we discuss. Question number 4, okay, you can do also crossover and mutation. The what we call how to represent the two type of representation of problem. So using GA. So I think dekat dalam notes pun ada discuss the Greek word problem. Yeah, we discussed just now tadi. So based on that idea, so maybe you can explain again by your own what we call own style. Okay, and then so this one also you can do on your try to what we call try to find the article that what happen if we decrease mutation and what happen if we increase the generation number, I mean the population. What happened to the performance of our program. Okay, this is the population. Okay, so discuss using influence on large population number of finding optimal solution in TSP, traveling assessment problem. So I think we have discussed already all this issue. So I think you can express based on your own style macam mana nak answer this all question. Okay, and then but for question number 2, give 3 reasons why is GA required to solve an optimization problem. Okay, 3 reasons. Okay, you can find in many articles actually for advantages of GA. But here I want to discuss about how to solve the best fruit juice. How to find the best fruit juice using optimization. Okay, so for example, we can do like this. Okay, best fruit juice, best juice. Okay, first variable, we have water. We should put some water to the juice. Then sugar, maybe. Fruit. Lagi apa? Ice. 5. Lagi apa? Milk. Kalau nak. Okay. Apa lagi? Takkan tak pernah buat juice fruit kat rumah.
Pernah, but rasanya tu sahaja.
Ini je kan? Okay.
Main ingredients, yes.
Okay, so we have 5 variables. So maybe we can put water represent, or A represent water, okay, B represent sugar, for example, C fruit, D ice, and milk for E. Okay, so because we have 5 variables, so we should define chromosome like this. We have 5. Okay, so the first one represent water. The second one represent sugar. Third one, fruit, ice, and milk. So we have 5 chromosomes. So for water, we need to define the minimum and maximum of water. Maybe the minimum water maybe 0, So you can no need put water, just fruit only, and then 300 ml. Okay, 100 ml is maximum water for 1 glass. Okay, so maybe you can put here lah macam ni lah, 0, 10, 20, 30, 40, 100 ml. And then sugar maybe you can put 1 gram to 10 gram for 1 glass. Kalau fruit, maybe 10 gram to 100 gram. Kalau ice, maybe 1 ice consider ml or gram?
Gram.
Gram. Okay, 0 gram to maybe 50 gram. Kalau milk, 0 to 100 gram. Okay, so after we define the what we call the variable, so for ice, you can put 0, 10, 50, 10, 20, 30, 40, and 60. So you need to define. Okay, lepas tu, after we define the variable, we need to generate, or we need to create mathematical representation for this problem. So f x, okay, a b c d e ni equal to a plus b plus c plus d plus e. So this is the maximum. So we assume the maximum value considered as the best chromosome quality. So you think this mathematical representation accurate or not accurate? Accurate or inaccurate? Suitable or not?
Not suitable.
To represent this problem, suitable or not suitable?
Yeah. I think not.
Kalau maximum macam tak suitable.
Yeah, not this not I mean not ideal. Okay, not ideal to represent the problem. So how to create the best finite function? This is very, very complex or difficult task. To generate the finite function for this case. But we just assume the best we just assume the finite function like this lah. Tapi the what we call the accurate one we cannot do, because some people like more sugar, but some people don't like sugar, but some people like ice, some people don't like ice. So we cannot what we call, we cannot do the finite function because many very relatives, okay, depend on individual, not general. That's why difficult to represent the finite function. But to what we call to polish our skill, how to learn the genetic algorithm work, so we can assume that our finite function look like this lah. Then we do some practice supaya we more have a skill lah to ni more clear how the genetic algorithm work. And then we assume this is our finite function, and then first we try to set the initial population. Maybe we can put 4 population by random. So the value for each ni we have 5 kan. So the value maybe 10, because we have ni kat sini we define the what we call the range of water, sugar, and so on. Then that one, the second one is sugar, but you must remember, water we using ml unit, but sugar we using gram unit. So we need to convert to percentage because we need to we should use same unit, standardized. We need to standardize the unit. So the best practice we using percentage lah. Clear? Sebab nanti kalau you put what we call ml, you mix and gram, so I think we cannot produce one good solution. So but we need to orang kata apa, standardize the unit, so we convert to percentage. So maybe 0 means 0%, 10 mean 10%, 20 mean 20% of water. Okay, sugar also 1 mean 10% because maximum 10 gram kan. 10%, kalau 2 gram mean 20% of sugar. Kalau fruit, same case. Okay, kalau ice 0 to 50. Kalau 10 mean equal 10 gram mean 20%. Kalau ice. Kalau 20 gram mean 40%, and so on. So the first one, the value of each sector ni by random. Okay, then we evaluate je. We evaluate the process, then repeat the process till we reach our number of iteration. For example, we set number of iteration 100, so we need to repeat 100 times. Clear tak? Yes or no?
Clear, sir.
Okay, so that one for how to using a genetic algorithm to find a best fruit juice. Okay. So dan yang lain-lain I nak you all buat, then submit through I discuss. Kalau ada soalan mana yang you rasa macam not sure or you not so you want to discuss, so ask me, then we discuss again. Question number 1 till question number 9. I think semua kita dah discuss. So I nak you all buat using your own style. Macam mana you nak, how to express the answer tu depend on you. Your based on your understanding. Okay?
Okay, sir.
So ada soalan? Kalau tak ada, I nak stop kat sini, then we communicate through WhatsApp, then I nak today you need to submit the what we call this tutorial. Today ke bila you boleh submit dekat I discuss? How many day you want? How many days you prefer to finish this tutorial?
How about Sunday?
2 days, 3 days, or today?
How about Sunday?
Till Sunday. Okay. So make sure
Yes,
before Monday you need to submit the tutorial. So I create one forum for tutorial 2. So you go to I discuss, then submit your answer dekat I discuss. I think you just using apa dia? No need to type lah sebab takut lambat. So you just gonna handwriting, then you snap, then after that you attach dekat ni, you dekat file, dekat Word, then you paste, then attach the file dekat I discuss, then siap lah. Alright?
Okay, sir.
Okay, bye. Assalamualaikum.
Sir, saya ada soalan.
Ha.
If kalau second iteration punya crossover tu sama macam first iteration, tak apa ke? Sebab kalau kita
Tak
guna
apa.
parents daripada first iteration,
Tak apa.
tak apa sama.
Kalau same quality, same value, so we just use the same answer, the same chromosome.
Okay.
That's why we should have mutation. Mutation tu by random kan. Kalau kita ada mutation, sure dia akan flip sikit lah yang mana tu. Sure akan ada different. Okay?
Okay, got it, sir.
Alright. Okay, bye. Assalamualaikum.
Thank you, sir.
Baik.
Waalaikumsalam. Thank you, sir.
Thank you, sir.
Thank you, sir.